Okay, so I'm Alex. I'm from Gifu University in Japan. We have been involved with Autoware for quite some time. Actually, before starting my lab at Gifu University, I was with Nagoya University, where Autoware was born originally. A professor there created Autoware for researchers by researchers. It was open. Then the same professor built a company in Japan, Tier 4. The person who was before here, Simon, is from Tier 4 company, developing Autoware projects in Japan. And Tier 4, with many other companies, created Autoware Foundation, and then Tier 4 transferred the software Autoware to the management of the foundation, and then the story continues, and we are an open source organization. So we have audio, I guess. I don't know. Let me see my participants, because it seems that the audio was dead before. I can see I think they can hear me. Okay. Right. So there are different tools available for simulation Autoware. I'm not going to get into the detail why it's necessary to have simulation. You may understand that better than me. Traditionally, Carla is one of the fundamental tools that was and is still being used for a relation with Autoware. At some point, it wasn't the strongest simulator environment. The LG company has the LBL simulator, which is already end of life, which had the backing from the company, and they were active in the Autoware Foundation. They provided multiple environments. They provided multiple solutions for the community. They provided environments and maps in many different maps that are not present in Carla. Carla has a very limited number of towns. Carla Garage may extend that, but still is constrained. But Carla is more traditional. It has plenty of publications done, different tools for benchmarking. And so the community is now reverting back to Carla because it's still the strongest simulation tool available. What it lacks is not that they are not doing anything, but it lacks still some realism, especially when objects collide. So that's where BeamNG comes in. So BeamNG is initially started in 2013. It's a gaming platform, which emphasizes and is maniatic in the level of realism and the physics reaction with the world. One of the things of BeamNG is that they decided not to rely on existing renderers for game renderers, game engines. They made their own. So BeamNG has their own game render. The renderer, actually the logo of BeamNG is kind of the core idea behind the render. They have nodes and links. The links include physics rules. So then you may have objects connected with some virtual connection or physical connection. Then that follows different physical rules. So when you crash, and then they have plenty of demonstration. They have amazing number of maps. And from the gaming tool, they started providing the sensor data, cameras, lidars, etc., in a solution that they call BeamNG Tech. And this is where we hook up with them. So what is available in BeamNG Tech? So what can we do with it? So as I mentioned, we have sensors that you can configure. You can not only have a camera, but you can have plenty of cameras. If you want to have a bird's eye view implementation with, say, 6 cameras, you can put the 6 cameras around, and then you can get the 6 the feedback with the cameras. You can have multiple style of lidars, and then you can have sorry, there's a problem with tool. So you can have scenario creation. You can tune, you can refine your maps. You can have, based on your maps, have different reaction with the agents on the environment. You have mode select, which can be based on autonomous, say, with an agent that drives autonomously, following the definition of the map. The autonomous mode can also drive following waypoints that you can define, or of course manual mode, which is how the game started as a tool for players. Anyway, one of the things that happened to be in my side of the world is that you don't get a lot of maps in Japan. So just before the last simulation, you can see what you can have in the middle when you crash. So let me go to the next slide. This one. One of the things that motivates us is the availability of maps in Japan, which is something that we don't get from other simulators. Meaning that you have the possibility to drive on the left side of the road. That small thing creates a domain gap. You train something on simulator, for example, Carla, driving on the right, and then you try that on a different side and don't work sometimes. So BeamNG has plenty of mapping, not only Japan, in plenty of environments in the world. So that will serve to close the gap. The other thing is that BeamNG is being actively used in publications. So just a few extracts of what they have, and they want to attract the community. So they kind of check which publications are referring to their simulator, and they just put the papers on their website. This is their website. What wasn't available as a way to connect BeamNG with Autoware, so that's where we entered. As I mentioned, we have opportunities to use BeamNG for applications in Japan. So not only maps, I have to say that the number of maps is not super abundant. We have like 4 or 5 different maps, but they are several kilometers long, and they are very realistic. The person insists in the realism of the scenes. So this is that over there is a road in Tokyo, and I just was comparing that road in particular with the real environment. Is very similar. A few elements in the surrounding of the environment, buildings maybe not so realistic. Of course, you cannot copy brands, and if you have the building of some bank, you cannot put that in the simulator. You have to replace the name or that kind of thing. They did. They have, of course, vehicles that are common in Japan, or at least the steering wheel is in the other side. So then you have variations in the point of view. If you are sampling from the driver's point of view, or you need to sample from different positions of the driving scene. For example, you're driving in the leftmost lane, etc. That's available for BeamNG. This is just a selection, just a selection, just to emphasize that we have finally simulators that include stuff in Japan. I will not say that this is the only one. Of course, the Autoware simulator OSIN was created, and among the different maps created, they are available in Japan. I don't know whether they have created other maps outside of Japan, actually, that also creates a gap. Only Japan is also not good. So variation is important. So BeamNG Tech works there. So we begin with creating a driving simulator. So with multiple screens, we have 3, what would be that? 50 inches screens combined together, the one that you can see in the leftmost video. And then we have the next level racing cockpit. Currently, it's not the articulated one, so you don't have vibrations yet. Need to do more to get that. We have haptic feedback, but that's not the core part of the hardware is not the core part of this talk anyway. We did want to provide more feedback to the drivers. So, for example, we also connected the steering wheel with BeamNG and also make it change the controller so that, for example, you can see the car is losing control and the steering wheel is also losing control. So then you can also get some more additional feedback when this kind of situation happen. Again, as I mentioned, the hardware is not the core part. Still having haptic feedback is very positive when you are having experimental subjects and then you want to get their impression. For example, whether the say one of the research we have done is subjective risk, so whether the driving improve or not their sensation of risk. But that's a little bit outside of discussion today. So up to now, just a brief discussion. So what is BeamNG? The other technology that we used, and then I'm going to explain why later, is Zeno. Zeno is a protocol, actually very low latency protocol that currently is being used as a replacement for DDS in ROS2. Already in ROS, there is a ROS Zeno DDS kind of bridge that you can get data across the Zeno protocol and then get the data back into ROS2 topics from one end to the other. So we are leveraging on using Zeno. I'm going to get more details into that later. And especially when you are driving using a simulator and then you need to, for example, from the pilot point of view, you have your vehicle remotely, your operated vehicle remotely. You want to get the data and operate that remotely. You want to decrease, of course, latency. We are doing this kind of remote operation research and also kind of simulator in the loop. So you have the simulator, the person, then the simulator is related to the environment, real world environment. So we want also to match these two things together, hardware and simulator. Right. So what we do, so BeamNG knows, so at least BeamNG Tech knows that ROS2 they know that ROS2 exists, and then they have already an interface for ROS2. So that we are not creating anything new, but was extremely slow. So you are getting a LiDAR. LiDAR is producing results assumingly at 10 hertz, but what we measure is when 1 hertz or 2 hertz. And not only that you have LiDAR, but you have multiple other sensors that you are trying to get. It's not the network latency issue, it's just at the same computer where BeamNG is operating, we just get the topics there, record the topics there, and then you get very low response time. So instead of using the native interface that they provided, then we step in and then created a bridge that we're going to get more details later on. So BeamNG Tech, I believe, I don't know whether they have a version for working Ubuntu. So our implementation has the simulator running in Windows, and then the client, for example, running Autoware in Linux. So that's how we have them connected. So then what we have is the Zeno BeamNG bridge that we created. It is open source. And then once we have the data passing through from Zeno, we can, yeah, yes, please.
Is this a VM or two physical machines?
Two physical machines. Yeah, so they can be connected. I mean, because the low latency, you can have them in different rooms. It's not that much problem. So no, it's not a bit machines. Yeah, by the way, if you have questions, just raise your hand. a little bit difficult to check on the online participants. Yes. So, right. So that's what we're doing. We have BeamNG. We use the Python interface that BeamNG provides, BeamNG Python interface. Created a Xeno-based bridge, and then we have that on transmitted, and then we can do anything what's necessary. Of course, our purpose is to use Autoware and then get the BeamNG data to Autoware and Autoware back to the control so that the BeamNG vehicle can move. But of course, you can do anything else. So it's not like tight integrated. It's not that the BeamNG Xeno bridge is completely fundamentally dependent on Autoware, so you can have multiple different applications. So this is what I mentioned before. It's difficult to show in this video, but basically because the two videos are different stuff. One is very choppy. 1 to top 5 hertz response that we obtained. The other one was just real time, no delays observed when we are getting the data. And then you can see actually the data being sent and visualized in RBs. So it is up after we pass the bridge and then get the Xeno to ROS conversion, and then what you can visualize it normally. So it was one small step there that we added into this implementation. So we have one end of the road. The other one, perhaps if you are familiar with Autoware, is not so complicated. Now you are able to get data from BeamNG. So what we do next? So Autoware needs maps to navigate, point cloud maps for the LiDAR localization. We need to have HD maps for the planner's navigation. So that means that we need to collect BeamNG's data, at least LiDAR's data, to get the point cloud. And then after that, based on that point cloud, use existing tools to make the SD map. And that's enough for the Autoware side. So yeah, you can use whatever mapping software you are familiar with. We use a lot LeoSam. If you check Autoware GitHub site in the tutorial wiki or the tutorial pages, you can find for mapping which are the existing solutions that can be used and that have been tested with Autoware. Some are ROS1 only, so then you need to meddle with the topics that the Autoware is using for LiDAR, for example. LeoSam is directly ROS2, so it is easy. You just need to have LiDAR and IMU. Both are provided via the bridge. So we are sending camera data, and we have LiDAR data and IMU data from BeamNG Tech back through the bridge to Autoware. So then we can record ROSBAC with this data. And then after that, just play the ROSBAC file, populate the topics, and then use LeoSam's, which also uses ROS2, connect with the proper topics, and then render the map. So again, I'm not this discussion is not about mapping, but if you have any questions about the mapping tools, of course, I'm happy to explain. But this is just the process of building the map as LeoSam is just executing. LeoSam again depends on IMU for posture correction. LeoSam is a graph SLAM method, so loop closure and everything is handled. So that's a correct tool. And for the HD map, we use the tier 4. What's the name? They used to tier 4 vector map tool, or vector map builder. I think is the name, vector map builder. So basically, both tools is available online, so you can use anything that you require. The vector map builder, I'm afraid, is by hand. So this was done by hand somebody. I guess we can use some automated tools for making langlets, but we did manual. So anyway, it was a low scale, not very large map, low scale. I mean, a few hundreds of meters. So that's basically East hand. But yeah, maybe other tools can be exploited. Then we have the point cloud for navigate for localization. We have a Langlet to map for necessary for planning. And then we have the necessary data. Okay, so once you have, yes.
Question for the concept, you said, so you get the point cloud in the
Yes.
Then you make all this map building, manual steps and so on, and then again you localize them.
Yes, so because we need to make a map, right? So Autoware needs this. BeamNG is not providing the map themselves.
I just want to ask, is it completely this work with this virtual approach? We don't need any real one, right?
Okay, well, if your map happens to be the same as the real world, yes. But no, this is within the virtual world. So I mentioned that BeamNG has a lot of emphasis in realism. There is a road in Japan that they also have in the simulator that's very much the same. But of course, there have been different changes in the traffic infrastructure, buildings gone or new buildings constructed. So that may decrease the performance of localization. We haven't tested cross real world versus simulation localization. That's something we haven't tested. So basically, this is a map in a mountain in Japan, Mount Tsukuba in Japan. So it is a mountain road. So we just get the data from the simulator into a ROSBAC file. Just record the LiDAR data and view data and camera data as they are we're providing. Then in an offline mode, we just get the LiDAR data with LeoSAM and other mapping tools to create the previous point cloud. Then once you have the point cloud, you have to create a Langlet map. That's the current Autoware universe depends on maps. That's one of the efforts of the community is to remove the dependency of that, but again, outside of the scope of this talk. So yeah, all that's done offline. Then assumingly you have the point cloud that corresponds to the virtual environment. So then you can link the two things together. There are some ride simulators that allow you to get directly in one go the map that you require. I think Carla provides that. Among the different things that Carla Bridge provides is the map itself, the point cloud map itself, and because they use Open Drive format for HTMaps, so then they are able to convert that into Langlet 2 and also send it as a topic. BeamNG doesn't have that yet. We have been working with the company to mention what we require. So this process of mapping maybe become unnecessary in the future if they are able, because they have the renderer. So they are able to export directly the point cloud maps and the road network. If that's available, then we don't need to do this direct. Yeah. Okay, so now that we have point cloud map, so then we get that's localization. So actually, some person is using the steering wheel, but showing the Autoware is keeping correctly its position, no matter if the car is just zigzagging along the road. So LiDAR data, the map is already, we have two computers. BeamNG is sending LiDAR data across the bridge. And then we have the already offline map that we created. So that's LiDAR data comes and then localizes with the map that we have in the Autoware side. And so you are able to get this kind of results. The other thing that you are seeing now is Autoware localizing. And then localizing, I mean, this is self-driving mode. So now we are in control of the vehicle. The video before was in manual mode. So somebody's just swinging the steering wheel. And then we can confirm the localization is working okay, because you can see here that the position of the car is correct in the world coordinates, or at least in the maps coordinates that we have. On the other side is BeamNG, and we are running Autoware. So here we are defining the destination somewhere there. So now planning is done, and then we can start driving. So that means now that there will be an inflow of topics from Autoware side to BeamNG, so that BeamNG is able to move the car. So there are some preparations that are necessary for that. I'm going to mention that in a moment. This is a map in San Francisco, I think. So the next is a hilly road, so it goes uphill, and well, the vehicle is driving correct. All right, so then we have shown that we have correct localization and correct self-driving. Then another thing that we have in BeamNG is that we can test. Autoware has been not tested, not conditioned, not tuned anything at all for bad weather, not for slippery road. But because the vehicle drives with physical soft body physics and understand about slippery roads and so on, then at some point the vehicle is going to slip, like now. Autoware loses control. Autoware doesn't know that the vehicle has slipped and then it is in a stale situation. That again is outside of the scope in this talk. Now we have a simulator tool that is able to provide that these kind of situations that others did not. So that's another, I think, very positive thing about including adding this BeamNG into the zoo of simulators that are available for the community. So we have other conditions for testing. So a little bit more into the technical details. So I mentioned, for example, that we have two sites, Windows side and the Linux side. The Windows side will have the BeamNG tech implementation. You need to get a license from the company. It's not complicated. The driver simulator itself, I think, is not open source. They have different modes for you to discuss with them, but of course, the game engine, like many cases, they do not share the code. But they have a great Python interface. That's the one that we are leveraging for this implementation. And then to transport data from BeamNG towards Autoware, and then because of the I mentioned before the issues with their ROS2 implementation, then we created Xeno BeamNG bridge. So basically, the code is available. I believe that at some point I have the link. So basically, just to transport everything that we found necessary in the Autoware side. And then on the other side, we have to convert from Xeno to ROS2. So Xeno bridge to DDS. So go back to ROS2 normal collection topics and then use that in Autoware. So a few more details. What you don't need, you don't need to send and send also. Therefore, we are able to create a configuration where we export what we think was necessary for Autoware. For example, IMU data, vehicle information, cameras. Some point it should be LiDAR, point clouds over there, etc., etc. So what we're providing, what kind of comments and what kind of a publisher will be getting the data is included there. And so there was a small technical issue in the implementation towards using Xeno, is that while we have BeamNG Python implementation, the connection with Xeno was slow. Actually, we need to serialize the data, and for that, the implementation in Python was not very efficient. So my student chose to use Rust. So well, it's very blurry here, but I don't know. Do I have a way to magnify this? No, I guess not. We have several orders of magnitude difference in time because of the issues with serialization. So we then selected this PyO3 library to use Rust functions in Python and reduce the time it takes to start sending the messages. Here is just for the point cloud data, but on the left side, we have, say, 70, 80 milliseconds, while in the other one we have, say, just the publishing time, just the serialization and publishing time, 1 millisecond or 1 nanosecond, 1 microsecond. So in some cases, 144 microseconds, which is sufficient in this case. That also yielded better performance. Non-serialized data transmission, very choppy, and then properly serialized, very smooth. So again, we don't want to get everything. Maybe BeamNG is producing more information that Autoware can handle. Different information, different topics that may be not relevant to Autoware. So then we also filter them in the configuration. As anything, BeamNG will have a coordinate system that may be different from Autoware, so we just had to do a coordinate transformation. One small thing in this implementation. Okay. I don't know whether I put that in the end. No, I didn't put it. If you look for Zeno BeamNG Rich, you'll find the open source implementation for this work. We've had some issues. We had some issues. For example, Autoware gets the data from the point. For example, just for the point cloud, among the different all the different topics. The point cloud has to pass through the point cloud preprocessor. So basically doing stuff like, for example, removing the crop box, removing or filtering out the data that you get from the LiDAR as the LiDAR is mounted on the car and it's perceiving the body of the car. For example, you don't want to get the bonnet of the car or the windows, etc., because that may affect the audio detector. So crop box, range filter, for example, if you want to filter your LiDAR data no more than some maximum distance, Autoware allows you to filter the data aligned with the lanelet. So if you don't want to get something that is very far away, that's not in your immediate vicinity, the LiDAR can provide you that, of course, but you want to concentrate in what is in the drivable area. Of course, Autoware has this kind of preprocessing functions in the space. But we found that there were several data missing that even if we follow the same structure, we were missing some data that the simulator is not providing, assuming that is 0 or something. So we had to do additional transformation. So basically do first a coordinate transformation according to what Autoware specs, follow the same preprocessor, and then we have to extend or modify the point cloud again to provide that kind of missing data. And therefore, the final transformation that we do to accommodate this missing data that the simulator was failing to provide or was providing some fixed data, fixed distance data, etc. We basically do that directly in the base link frame, which is after all this point cloud preprocessor happens. One important thing that is still a limitation that other simulators do have is that BeamNG Tech doesn't have proper intensity, LiDAR intensity information. The point cloud format that Autoware uses part of the Cartesian coordinates, as I said. It requires intensity information, requires timestamp information, the range information, and many other different fields. We cannot accommodate to that. But we try to provide some solution to this intensity not available data. I mean, this kind of issue is to just simulate intensity with some artificial value. It is not implemented yet. Other simulators do produce intensity based on the color of things. That's what Carla does. You get the RGB, say you have asphalt, black asphalt, or you have a marker on the road that is whitish. So the RGB color is transformed into intensity inside the simulator. So it's something that we could mimic. That's not, of course, that's not the best. We have done research before, tried to understand the properties of materials, and then what's the proper way to do simulation of the physics of photonics behavior when the LiDAR of some wavelength reacts with some materials. Of course, that's extremely time consuming, but that's of course the ideal way to do that. But also that also requires a very deep integration with the simulator. Again, we are not getting into that. So one of the things that I just wanted to finalize in this slide is that we accommodate the point cloud, even if some data is missing, to what Autoware is requiring in different stages. Okay. So what else is necessary? So when you see the code, if you want to check on that, basically Autoware in the source code has sensor kits. So you have the core functionality, but if you have your own vehicle implementation, so there will be part in your source code structure when you create the launch files that define, or the configuration files, the parameter files, where you have your vehicle according to the vehicle physical properties, where you have your sensors, what is the TF tree of your sensors in your car implementation. So we also did that for some cars. And also what's the sensor kit? So what sensors are imported or are being provided in the car? So we have a branch from the vehicle interface, the sensor kit are sub repositories. So we clone that repository our own. So we provide a few of those configured vehicles as well. So you can understand what is how to tune things. One of the final thing that was necessary is towards the low level control of the vehicle, how the vehicle reacts when you are pressing the pedal in your simulator tool. Say we're using logical G29 with the pedals. So when you are pressing the pedals, not the same as a real car. So how to convert that into the necessary acceleration curves that Autoware needs. So Autoware has the acceleration brake calibrator tool inside the source code. So what we need is this is actually coming towards how to drive the car. Go to Autoware. Autoware will produce some information, and then you need to get that information back to BeamNG and drive the car in a realistic manner. So to do that, we need to also accommodate what Autoware is producing and then what BeamNG is expecting on the car control. So to have that done in a way that is natural to Autoware, so we use this acceleration brake calibrator. That's already existing tool, as I mentioned, for multiple cars. But basically, it produces an Ackermann control command. But BeamNG is expecting something called the actuation command. So we have this Autoware raw vehicle controller converter. Then we can map from that particular type of topic into the one that BeamNG is expecting. and then accommodate to the proper acceleration curves, etc. So in order to have a vehicle that is reacting as you expect. So then it's not just you create your car, you create your environments. You also configure your vehicle, your parameters of the vehicle. If you are driving on off-road environments, so then you also can run here to get the proper acceleration and braking curves according to the environment that you're using. And then this at the same time will give us the calibration map and also give us a way to get the necessary commands that BeamNG is expecting on the other side of the pipe. And yeah, so this is another example of BeamNG. This is a GIF file. So BeamNG window is on the left, Autoware is on the right. This is the camera being sent via Leno bridge from BeamNG to Autoware for Autoware to handle. The point cloud also, of course, available, localization, everything is running. And then the vehicle control is being transmitted, the actuation command being transmitted to BeamNG, and then the vehicle is driving. So a bit short, the presentation a bit short on time. This is the talk that I had prepared for today. The code is available, it's open source. If you enter the GitHub site now, maybe you will see everything in Japanese. We are also working towards multiple languages. These manuals are going to be also there. We have presented this last year at the similar working group in the Autoware Foundation. We invited BeamNG also to join, so they shown what the simulation tool is available, what can they do. Now there is an interest in the community. I'm really happy that among those are you guys sitting here hearing my talk. As I said, one of the great things of BeamNG is that it provides lots of maps, not only Japan, but in different conditions. For example, off-road is taking a lot of interest in the Autoware community now. So there's even a working group called the Off-Road Driving, Off-Road Working Group. They have tremendous amount of maps in off-road. In my lab, we are working in rallying, autonomous rallying. Not yet in a physical vehicle, we are dreaming towards there. But one of the things that BeamNG also provides is the pace notes. So then you have the text that corresponds to the driving. Now you have the text either via speech or the actual text. Then you can train BLM or something. That's what we're currently doing to get autonomous. Like we're trying to do two things. The pilot that gets the feedback from the co-driver as text and then makes the decisions as an end-to-end system. And the other thing that we want to implement, because BeamNG provides pace notes, but they are not automatic. They exist for some maps, but it would be great to leverage this text for other environments. So also we're trying to automatize the co-driver. So to have the two roles and maybe have different networks, human with AI co-driver or AI driver with human co-driver. That's among the things that we are considering, and then this tool has been great for that. Yeah, so I think that's the contents of my talk. If you have any questions.